Hello, welcome back to L'Hopital's rule. So I'm going to go ahead and use L'Hopital's rule and do a couple more examples here. And you'll notice one thing with my first example right off the bat. You see this x times natural log of x? Well, that looks like a product, but it's supposed to be a quotient. So how do I fix this? This needs to be fixed. Okay, so we're going to use a sneaky little rearranging trick. So remember, L'Hopital's rule, it has to be the quotient of a function. It's got to look like this, right? It's got to be the limit of a function divided by a function. So this is what you're striving for in order to use L'Hopital's rule. And I don't have that here. So here's my sneaky little trick. I am going to turn this into a stacked function by doing this. Natural log of x on the top and 1 over x on the bottom. Now, you might at first say, hey, this is not the same as that. But let me convince you that it is. Suppose I multiplied the top and bottom by x. Well, look at what you would get. The x would divide by x on the bottom, so that would all cancel. And you'd be left with x times natural log x, which, guess what, is our original function. So let's get that out of there. So that's perfect. So I'm back in business. Now the question is, now that it is stacked as a quotient, can I use L'Hopital's rule? So I am going to plug in 0 as we approach it from the positive side, and that would send natural log down to negative infinity. And when I put in 0 in the bottom here, 1 divided by a very small positive number would also send it to infinity. It doesn't matter that it's negative infinity over infinity. What matters is it's infinity of some kind over an infinity. So that is an indeterminate form, which means we have the green light to use L'Hopital's rule. So now away we go. Okay, so I'm going to go ahead and differentiate the top. I'm going to differentiate the bottom. I'm going to think of this guy as x to the negative 1. So I can use the power rule. So that's going to be negative x to the negative 2. Now it looks awful, but it really cleans up quite nicely. So let's have a look at it. With a little bit of cleaning, a little bit of soap. Let's put the negative with the 1 over x on top. And on the bottom, I have 1 over x squared. So I am going to multiply the top and bottom by x squared. That'll clean that up a little bit. Okay, so what are we looking at here? Limit as x approaches 0 from the right, and I have negative x on the top and essentially 1 on the bottom. So now if I'm plugging in really, really small numbers that are approaching 0, and there happens to be a negative sign in front, it really doesn't make any difference. I'm still going to 0. So that is my answer. Okay, on to my second and last example. Notice here, we also don't have a function divided by a function. So what are we going to do to clean this mess up? Well, first of all, let's change those trig functions into sines and cosines and then see what we're dealing with. So secant is 1 over cos, and tangent is sine over cos, and all of a sudden, it's very clear to me that I can just add the two fractions together, combine them. So here's what my limit now looks like. So limit as x approaches pi by 2 from the negative side. I'm going to make this one fraction. 1 minus sine of x. And on the bottom, the common cosine. So what we've done is we've created a function divided by another function. Okay, that's always the key to L'Hopital's rule. Now I have to decide, am I allowed to even use L'Hopital's rule? So let's plug in pi by 2. Now pi by 2 is like 90 degrees. So this is like saying 1 oh, that doesn't look very good. Right? My 1 looks like a bracket. Let's clean that up. Okay, so try that again. 1 minus sine of 90 degrees, or sine of pi by 2, which is 1. So that's going to be 0 on the top. And cosine of 90 degrees, or cosine of pi by 2, which is 0. So that looks like 0 over 0, and that means an indeterminate form. I am using L'Hopital's rule. So now I'm going to take the derivative of the top and the derivative of the bottom. Okay, so the derivative of 1 is 0, and then negative sine, the derivative of that is negative cosine. And on the bottom, the derivative of cosine is negative sine. So I don't have to worry about the negatives anymore, and what I'm going to do is just plug in the pi by 2. Cosine at pi by 2, or 90 degrees, is 0. And the sine at pi by 2, or 90 degrees, is 1, which means my answer is 0. And I think that's a good place to stop. Okay, one more L'Hopital's video after this, and then that's it for L'Hopital's rule. Catch you later.